my name is Janek Alfonso, the leader of Group 5. The task given to our group is separation using sedimentation, decantation, and centrifugation.
I'm Kathleen Hungay with Gian Christian Fry, and we're gonna discuss about the principle, technique, safety, and application of sedimentation process. Sedimentation is the deposition of sediments. It takes place when particles in suspension settle out of the fluid in which they are entrained and come to rest against a barrier. So, meaning the heavier particles present in a liquid mixture is nasa baba ng glass after leaving it undisturbed for some time. For example, a mixture of sand and water, and then yung sand is nagsisettle at the bottom, and that's called sedimentation. The next slide is technique while doing the sedimentation process. First is get a liquid mixture. Example is water and mud that mix together in a beaker. Stir the mixture well and then leave it undisturbed until the heavier particles settle at the bottom. Yung mud ay nasa bottom ng beaker because of the process of sedimentation.
The safety in using sedimentation process. This is achieved by reducing stream velocity as low as possible for the longest period of time possible. This is feasible by widening the approach channel and lowering its floor to reduce flow velocity. This allowing sediment to settle out of suspension due to gravity. The application in using sedimentation process is used to reduce the particle concentration in the water. The advantage of sedimentation is that it minimizes the need for coagulation and flocculation. Typically, chemicals are needed for coagulation and flocculation, but improved sedimentation controls the need for additional chemicals.
Decantation works on the fundamental principle that heavier, denser material sinks, while lighter, less dense material float. Decantation is the process of using gravity to separate two immiscible liquids or a mixture of solid and liquid. The mixture lighter component is dampened or sucked up of the top. In decantation, the clear upper liquid is poured out from the container without disturbing the sediment. Decantation technique. Loading is the process by which the mixture of liquids and liquid containing tiny impurities is separated by adding chemical that stick to the impurities and makes them heavier. This procedure can also be used to separate two liquids that do not mix with each other. For example, oil and water. The oil-water mixture forms two distinct layers with water at the bottom and oil at the top. For example, if we leave a bucket of water and mud or sand, the insoluble particles will eventually settle at the bottom of the bucket. Liquids that are miscible do not mix together to produce a solution.
Safety. Decanting a mixture containing flammable solvents can be dangerous as the material evaporates and forms dangerous fumes. This mixture is an example of often cited as a safety hazard by the fire services. Application. Decanting is the process of separation of liquid, solid, and other immiscible non-mixing liquids by removing the liquid layer at the top from the layer of solid or liquid below. The process can be carried out by tilting the mixture after pouring out the top layer. Decantation is to purify a liquid by separating it from a suspension of insoluble particles. Example, in red wine, where the wine is decanted from the potassium bitartrate crystal to avoid unsavory taste.
Good day, I am Miles Michaela B. Miranda together with Harold C. Solomon, and we are going to tackle about the separation using centrifugation. We have two principles of centrifugation. First, in a solution, particles whose density is higher than that of the solvent will sink, and particles that are lighter than it float to the top. So, dahil sa radial acceleration mula sa centrifuge, ang denser particles ang lumulubog sa ilalim ng sample tubes, habang yung mga lighter materials ang lumulutang sa ibabaw. Second, the greater the difference in density, the faster they move. If there is no difference in density, the particles stay steady. So, when separating particles in a solution, pwedeng palitan ng centrifugal forces ng gravity para mas matake advantage even though the smallest differences sa density.
Techniques in centrifugation. There are three types of centrifugation techniques. First is the density gradient centrifugation. Second is the differential centrifugation. And third is the ultracentrifugation. But before I start with the types of centrifugation techniques, as you see on the left side of your screen, those are some of the processes of centrifugation. First, in a centrifuge, as we rotate the substances, experience centrifugal force away from the center which forces the materials against the wall of the tube. Second, a mixture of pi-suspended particles is taken in a test tube and taken in a liquid. Third, due to the action of the force, the heavy suspended particles settle down to the bottom. And what is indicated in the picture is the example of the centrifugation processes. So, let's start with the techniques. First is the density gradient centrifugation. It allows the separation of many or all components in a mixture and allows for measurement also. And there are two forms of density gradient centrifugation. One is rate zonal centrifugation, and the second is isopycnic or sedimentation equilibrium centrifugation. In rate zonal centrifugation, the solution has a density gradient. The sample has a density, therefore greater than all the layers of the solution. The sample is applied in a thin zone at the top of the centrifuge tube on a density gradient. Under centrifugal force, the particles will begin segmenting through the gradient. In isopycnic centrifugation, the solution contains a greater range of densities. The density gradient contains the whole range of densities of the particle in the sample pool, stopping each particle with sediment only to the position in the centrifuge tube at which the gradient density is equal to the bone density. In isopycnic centrifugation, the solution contains a greater range of densities. The density gradient contains the whole range of densities of the particle in the sample pool, stopping each particle with sediment only to the position in the centrifuge tube at which the gradient density is equal to the bone density. The next technique is the differential centrifugation. It is a common procedure in microbiology and cytology, useful to separate certain organelles for further analysis of specific part of cells. Next and last is the ultracentrifugation. The first commercial ultrafuse was produced in 1940. An important tool in biochemical research is the centrifuge, which through rapid spinning imposes centrifugal forces on suspended particles or even molecules in solution, and causes the separation of such matter on the basis of ultracentrifugation of differences in weight.
Next, we have safety consideration when operating a lab centrifuge. First, use the centrifuge on a level surface. So, yung mga tools and equipment kailangan nasa secured place. Kasi if wala, pwedeng may maapektuhan sa components ng machine na dahilan kung bakit nasisira ang mga machine. Second, monitor the centrifuge. So, always check the device before, during, and after use para malaman kung may mali sa pag-run ng machine. Example, if may vibration or different noise. So, ipacheck ka agad sa experts para maagapan kaysa mas maging risky pa. Third, check the maximum load tolerance and speed. Kailangan malaman kung ano ang maximum load tolerance at bilis na kaya ng makina. Kasi kung gagamitin with larger load at the maximum speed, it could result in mechanical failure that may lead to an accident. Fourth, inspect and balance tubes correctly. Dapat suriin yung conditions ng mga tube at kung compatible yung mass and volume sa application during the process. Kasi ang mga tubes ay dapat match set sa centrifuge for safe operation. May ilang units kasi na may imbalance sensor. Kapag na-sense na hindi balance, the unit will stop running immediately. Fifth, keep the lid closed during cycles. So, just in case na magkaroon ng problem sa rotor during the process, sa paggamit ng takip, mapapanatili yung kaligtasan ng mga nakapaligid sa machine. It's either tao or mga gamit din. 6. Wait before opening the centrifuge. So, para mas ma-prevent yung exposure ng aerosol, kailangan maghintay for a period of time hanggang sa ganap na tumigil yung makina bago i-open yung centrifuge.
Next is the application of centrifugation. The process of centrifugation has a wide spectrum of industrial and laboratory scale applications. In this technique, a centrifugal force is applied to the solution in order to separate the highly dense components of the solution from the components that have relatively low densities. There can be three cases of separation of a mixtures. First is the separation of mixture of two solids. Here, a mixture of two solids can be separated from each other by using a solvent which will make one of the substances soluble in the solvent, thus separating the two substances. For example, a mixture of sugar and sand can be separated by using water as a solvent, as sugar is soluble in water and sand is insoluble in water. Next is the separation of a mixture of solids and liquids. Centrifugation separates the components of heterogeneous mixtures. These include liquids and liquids, solids and liquids, and solid and liquids and gases. Centrifugation uses centrifugal force to move dense components to the outside of the container. And last is the separation of a mixture of two liquids. Solid particles in a liquid can sometimes be so minute that they can pass through a filter paper. The filtration technique cannot be utilized to separate such particles. The centrifuge is made up of a centrifuge tube holder known as a roller. On the left side of your screen, that is the centrifuge machine used and the centrifuge uses in the laboratory. Centrifugation can be utilized to separate a mixture of two distinctive miscible fluids. This technique can likewise be utilized to contemplate and examine macromolecules and their hydrodynamic properties. Centrifugation is known to have an essential part in the fractionation of numerous subcellular organelles. Moreover, centrifugation is likewise valuable in the fractionation of layer fusion and films. Centrifugation additionally has application in the fractionation of layer vesicles. On the right side of your screen is the list of some examples of centrifugation. The extraction of fat from milk in order to produce skim milk. The removal of water from moist lettuce with the help of a salad spinner. The spin drying of water in washing machines in order to remove water from the clothing. And last, the separation of solid blood and urine materials into forensic and testing laboratories.
That concludes our presentation. However, I'd like to quickly summarize the main points. Sedimentation can be used to separate particles based on their size by applying a centrifugal force to the required solution. Decantation follows sedimentation. The decantation process involves pouring clear upper liquid out of the container without disturbing the sediment. And lastly, centrifugation. A centrifugal force is applied to an heterogeneous mixture which will separate the mixture according to its density. That's all for our presentation. I'd like to thank you for your time and attention. Thank you.